Today we are going to see chemical energy sources. The first topic will be the fuel cell. So we all know that batteries which generate electricity from the chemical energy, but in the battery we don't charge, we don't add any materials, but we have a finite quantity of material, and that will be producing the electricity. And once the capacity to yield the energy decreases, the cell will get exhausted, and then we have to go for a new cell. But in case of a fuel cell, it's not like that, where the fuel, which is a fuel, will be having a chemical energy, and this cell utilizes this chemical energy continuously and produces the electricity. This is the output. So this fuel has to be continuously fed to the cell, and the cell will be producing the electricity continuously. That is the difference between an ordinary battery and a fuel cell. I repeat once again, a fuel cell uses a fuel. In the fuel we have a chemical energy. This chemical energy is used by this cell, fuel cell, and it produces the electricity. So it takes place, it is a continuous process as long as you supply fuel to the cell. But in case of the batteries, we don't supply anything to it. The material is finite, and once the energy producing capacity decreases, the cell will be dried off and it will be replaced by a new cell. But in the fuel cell, we continuously send the fuel to the cell, and the cell produces the energy continuously. That is the major difference between a fuel cell and an ordinary battery. Then, in majority of the cases, in the fuel cells, we will have an electrolyte which is present in between the cell, and cell will be having a positive terminal, and the cell will be having a negative terminal. Positive terminal of a battery is called as the anode, and similarly the negative terminal of a battery is called as the cathode. And then we have an electrolyte here, and then the fuel will be supplied to the negative terminal of the battery continuously, and then oxygen will be supplied to the positive terminal of the battery continuously. So hence we produce the current here, and then electricity will be generated. But the most important thing is continuous supply of the fuel and oxygen is must for the generation of electricity in a fuel cell. But in batteries, the stored fuel is converted into the electricity. That is the major difference between a fuel cell and a battery. Now, what are the classifications of the fuel cells? Fuel cells are broadly classified on the temperature basis, on the electrolyte basis, and on the physical state of the fuel, how we are going to supply. So based on the temperature, they are categorized as low temperature fuel cells, where the temperature ranges is 25 to 100 degrees centigrade. If the cell operates in this temperature, it is called as low temperature fuel cell. Suppose if the cell operating temperature is in between 100 to 500, then it is called as moderate temperature fuel cells. Suppose if it is 500 to 1000 degrees centigrade, then it is called as high temperature operating fuel cell. And suppose if it is greater than 1000, it is called as very high temperature operating fuel cell. Now, based on the electrolyte, as I said in the previous slide, the presence of electrolyte is a must, and if the physical state of the electrolyte is aqueous, we call it the aqueous fuel cell, non-aqueous fuel cell, and if a molten material is present, that is a molten material fuel cell, and of course if you have a solid, it is called as a solid fuel cell. And how we are going to supply the feed if it is a gas. So in majority of the cases we supply hydrogen to it, or lower molecular weight hydrocarbons limited up to propane. So here these kind of fuel cells are called as gaseous fuel cells, where the nature of the fuel is a gas. Suppose if you go for the liquid phase, then we can supply alcohols, we can supply hydrogen, and higher molecular weight hydrocarbons we can supply, and then we can produce electricity. And certain metals are there which can also give this the electricity in the fuel cell. So these are the broad classifications of the fuel cells. Fuel cells are classified based on the operating temperature, based on the physical state of the electrolyte, based on the physical state of the fuel which we are supplying to the fuel cell. Then the types of the fuel cells are the hydrogen fuel cell, the fossil fuel cell, hydrocarbon fuel cell, alcohol fuel cell, hydrogen fuel cell. And what are the applications of these fuel cells are? They are used in domestic use, they are used at central power stations, automotive vehicles, and in special applications where we find the application of the electricity or the power or the energy is limited to a primary source or backup source. There we can use these kind of energy states. Then typically if you look into any of the fuel cells, this will be the diagram where we are using 40% of aqueous KOH. So hence its category is what? Aqueous electrolytic fuel cells, and the source of fuel is hydrogen. So we are using hydrogen, a gas, so we can also call it as a gaseous fuel cell which is operating on aqueous electrolyte. This is the description of these fuel cells. So this hydrogen is now sent to the chamber, and then in this chamber we have two electrodes, permeable electrodes, which are made up of the nickel, and the character of this is it can allow only the passage of hydrogen ions through this. And at this point we have electrolytic catalyst which will be converting the hydrogen to hydrogen ions and electrons. So these hydrogen ions will be going through this, whereas the electrons will be going out, and from here they come out. So when they come out from an external source, we trap them here and pick up the ends. Whereas these hydrogen ions which are coming here, they will be reacting with the oxygen, and then they will form hydrogen ions, they will be forming the H2O. So this will be giving these reactions, and then the water will be going out. So we supply the hydrogen at the negative terminal. Always important, the fuel should be entering the fuel cell at the negative terminal, and the source of oxygen should be sent to the anodic terminal, and here the electrolyte plays a vital role. So as the electrolyte concentration decreases, it will be sent inside, and then the depleted electrolyte will be taken out from here. And these two are semi-permeable membranes which will allow the permeability of only hydrogen ions. This is very important, and these electrons will be traveling through the external route, and thus we take up the energy from this process. This is one more example where we are using a solid type of the electrolyte, where hydrogen enters the negative terminal of the fuel cell, and the air or oxygen will enter the positive side of the electrode, and then these hydrogens will be splitting up, and these two hydrogens, these H and H, which will become the 4H protons, and they go from here, whereas the 4 electrons will go take the external route. They can, because these electrons are not able to pass through this semi-permeable membrane. They are forced to take out from the external route, and when they go out, we take them and then we pick up the heat. We pick up the energy, and then this oxygen at the surface, what they will become? They will react with protons, and then we get the 2 moles of waters. And from pollution point of view, they give eco-friendly water, which is the success of these fuel cells, and there are no wastage parts are there present. Now, fossil fuels can be used for generating the fuel cells. The previous slide is same, but here we have a fuel processor. The fossil fuels are enriched in this fuel processor, and then mainly we take out the hydrogen. So if you remember the manufacturing of coke oven gas, in the coke oven gas manufacturing unit, we are going to use coke, and then we are going to produce coke oven gas, and then afterwards the coke oven gas we are going to eliminate all other ingredients like CH4, like CO2, like CO, and then hydrogen is enriched, because there we have seen that India is an agrarian country, so this hydrogen can be mixed with nitrogen to form ammonia, and ammonia is a starting raw material for urea. So every petrochemical industry can also have a urea manufacturing industry, and this is another alternative route that the fuel, fossil fuel is sent to the fuel processor, and there we are going to get hydrogen mainly, and this hydrogen is sent to any one of the previous slides to produce the electric current. So we take air from here, and the water whichever is obtained from this, that is at a high temperature, if it is operating below above 100 degrees centigrade, we get steam, and this steam can be used for this. Okay, so from here electricity we get DC, because any current which is obtained from a fuel cell is a direct current. So this direct current is sent to the inverter, where it is converted to AC current, because this AC current is the need of the energy in our domestic sector. So DC current has to be converted to AC current, which will be useful for the grid supply.